Assalamu alaikum wa rahmatullah. Welcome to the last video of our lesson Elemental Analysis. Today we are going to talk about Quantitative Elemental Analysis. By the end of this video you will be able to use the results of quantitative analysis of a compound to determine the percentage mass of its elements, distinguish between empirical and molecular formula, and find the empirical formula and molecular formula of an organic compound. The materials needed during this session are a pen and a notebook and a worksheet you're supplied with that includes the main ideas and terms mentioned in the video. Let's recall back that an organic compound is a compound which contains one or more carbon atoms. Elemental analysis aims to determine the nature of the elements present in an organic compound as well as to know how much of each element is present. The elemental analysis is divided in two parts. The first part is qualitative elemental analysis, which we talked about, and the second part is quantitative analysis, which we are going to talk about in this video. Qualitative elemental analysis allows the identification of the nature of the elements in an organic compound. But what is quantitative elemental analysis? The quantitative elemental analysis is the determination of the relative amounts of each element that make up an organic compound. For example, an organic compound is made up of the elements carbon, hydrogen, and oxygen. We have to find the relative amounts of these elements in this compound. This is quantitative elemental analysis. Elemental quantitative analysis allows the determination of the percentage by mass of each element that make up the organic compound. The percentage composition by mass of the different elements that make up an organic compound enables us to determine its empirical formula. What is the empirical formula? That's what we are going to see now. Empirical and molecular formula. First, the empirical formula of a compound containing carbon, hydrogen, and oxygen, for example, is given in the form CXHYOZ, where X, Y, and Z are integers. These represent the smallest number of atoms or mole atoms of the elements carbon, hydrogen, and oxygen in the organic compound. While the molecular formula of a compound shows the actual number of moles of each element in 1 mole of the compound, it is represented by CXHYOZ N. It is very important, where N is an integer that can be determined only from the molar mass of the compound. For example, glucose, whose molecular formula is CXC6H12O6. We can represent its molecular formula by CH2O between parentheses 6. What is this 6? This 6 is the GCF of 6, which is the subscript of carbon, 12 the subscript of hydrogen, and 6 which is the subscript of oxygen. By dividing all these subscripts by 6, we get CH2O, and we put parentheses and we put the GCF. This is N, which we talked about here. Now the empirical formula of glucose is just CH2O without this N. For example, another example, vitamin C, whose molecular formula is C20H30O. The GCF of 20, 30, and 1, which is the subscript of oxygen, is only 1. So the representation of the molecular formula is C20H30O, and 1 is N. N is 1. Now, the empirical formula, we write the molecular formula, the representation of the molecular formula without N, so the empirical formula is also C20H30O. Here, the empirical formula is the same as the molecular formula. The rules that should be followed in quantitative analysis are: the first rule is the percentage by mass of any element X, carbon, hydrogen, oxygen, etc., is equal to the mass of this element over the total mass of the compound times 100. The second rule, for a compound of molecular formula CXHYOZ, we use the law of definite proportions, which we are going to see how can we determine this law. The molar mass of this compound over 100 is equal to the molar mass of carbon, which is 12, multiplied by the subscript of carbon, which is X, over the percentage by mass of carbon, is equal to the molar mass of hydrogen, which is 1, multiplied by the subscript of hydrogen, which is Y, over the percentage by mass of hydrogen, is equal to the molar mass of oxygen, which is 16, multiplied by the subscript of oxygen, which is Z, over the percentage by mass of oxygen. To find the formula of the law of definite proportions, first we know that the percentage by mass of carbon is equal to 12, which is the molar mass of carbon, multiplied by X, which is the subscript of carbon, over the molar mass of the compound times 100. Then we can write the molar mass of the compound over 100 is equal to 12x over the percentage of C. This is the first part of this formula. We also know that the percentage by mass of hydrogen is equal to the molar mass of hydrogen, which is 1, multiplied by the subscript of hydrogen, which is Y, over the molar mass of the compound times 100. Then the molar mass of the compound is equal to is equal to Y over the percentage of hydrogen. Also, the percentage by mass of oxygen is 16Z, molar mass of oxygen, times Z over the molar mass of the compound times 100. Then the molar mass of the compound over 100 is equal to 16Z over the percentage by mass of oxygen. Then we get the law of definite proportions, which is molar mass of the compound over 100 is equal to 12x over percentage of carbon, Y over percentage of hydrogen, and 16Z over percentage of oxygen. Now watch this video carefully.
Quantitative analysis. This analysis gives the percentage composition of elements present in an organic compound. Percentage composition of carbon and hydrogen. A known mass of an organic compound is burnt in the presence of excess of oxygen and copper to oxide. Carbon and hydrogen in the compound are oxidized to carbon dioxide and water respectively. The mass of water produced is determined by passing the mixture through a weighed U-tube containing anhydrous calcium chloride. Carbon dioxide is absorbed in another U-tube containing concentrated solution of potassium hydroxide. These tubes are connected in series. The increase in masses of calcium chloride and potassium hydroxide gives the amounts of water and carbon dioxide from which the percentages of carbon and hydrogen are calculated.
Note that in this video we use the anhydrous calcium chloride instead of sulfuric acid. Both compounds have the same role, they absorb water. In the first previously weighed U-tube, water is collected, and in the second previously weighed U-tube, carbon dioxide is collected. Now, how to determine the mass of water and carbon dioxide produced? We said that KOH absorbs CO2 and H2SO4 or CaCl2 absorbs water. Before the experiment, the mass of the second U-tube was 4.02 grams, while the mass of the first U-tube was 2.86 grams. After the experiment, the mass of the second U-tube increases to become 4.55 grams, and the mass of the second U-tube increases to become 2.97 grams. To determine the mass of CO2 and the mass of H2O, we subtract the masses of the U-tubes before and after the reaction. We get that the mass of carbon dioxide produced is 0.53 grams and the mass of H2O produced is 0.11 grams. To know how to determine the empirical formula of a compound, let's solve application 1. The combustion of 5 mg of organic compound containing carbon, hydrogen and oxygen produces 12 mg of carbon dioxide and 6 mg of water. Find the empirical formula of this organic compound. To find the empirical formula, we should find the percentage by mass of each element in the compound. This is the first step to determine the empirical formula of any compound. To calculate the percentage by mass of carbon, we must follow these steps. First, we write the equation of combustion of carbon. Carbon plus oxygen gives CO2. According to stoichiometry, the number of moles of carbon over 1 is equal to the number of moles of carbon dioxide over 1. Then, the number of moles is equal to mass over molar mass. Then the mass over molar mass of carbon is equal to mass over molar mass of carbon dioxide. The molar mass of carbon is 12. the molar mass of carbon dioxide is 44, and the mass of carbon dioxide produced is 12 milligrams. Then the mass of carbon is equal to 12 times 12 over 44 equals 3.27 grams. We can now find the percentage by mass of carbon is equal to mass of carbon over the mass of that compound, the total mass of the compound, times 100 equals 3.27 milligrams over 5, which was given, times 100 equals 65.4%. Now, to calculate the percentage by mass of hydrogen, we must follow these steps. First, we write the equation of combustion of hydrogen gas, H2 plus half O2 gives H2O. H2O is formed from its elements. According to stoichiometry, number of moles of hydrogen over 1 is equal to number of moles of water over 1. Then mass of hydrogen over its molar mass is equal to mass of H2O over the molar mass of H2O. Then the mass of hydrogen over 2, which is the molar mass of H2, is equal to 6, which was given also, the mass of H2O, over the molar mass of H2O, which is 18. Then mass of H2 is equal to 2 times 6 over 18 equals 0.66 milligrams. And the percentage by mass of H is equal to mass of H over the total mass of the compound times 100 equals 0.66 over the total mass of the compound that we burned, which is 5, times 100 equals 13.2%. Here, note that mass of hydrogen is equal to mass of H2. Now, to calculate the percentage by mass of oxygen, follow these steps. According to the application, the organic compounds carbon, hydrogen, and oxygen only. We found the percentages of carbon and hydrogen, then we can find the percentage by mass of oxygen. Since the sum of the percentages by mass is equal to 100%, then the percentage by mass of oxygen is equal to 100 minus 65.4, which is the percentage by mass of C, plus 13.2, which is the percentage by mass of hydrogen, equal 21.4%. Now, to find the empirical formula of the organic compound CXHYOZ, we use the law of definite proportions. We say that the molar mass over 100 is equal to 12x, which is the subscript of carbon, over percentage of C, equal y over percentage of hydrogen, equal 16z over percentage of oxygen. Now we must find x as a function of z. Then we take 12x over percentage of carbon is equal to 16z over percentage of oxygen. Then 12x over 65.4 percentage of carbon is equal to 16z over 21.4, which is the percentage of oxygen. Then x is equal to 65.4 times 16z over 12 times 21.4, approximately equal 4z. We also must find y as a function of z. We say that y over the percentage of hydrogen is equal to 16z over percentage of oxygen. Then y over 13.2 equals 16z over 21.4. Then y is equal to 13.2 times 16z over 21.4, approximately equal 10z. Then we can write the empirical formula as C4z instead of x, H10z instead of y, and OZ. For z equal 1, the empirical formula will be C4 times 1, C4, H10 times 1, 10, and OZ, it means O1. Now, how to find the molecular formula of a compound? The empirical formula of the compound we have found was C4H10O. Find the molecular formula of this organic compound if the molar mass of the compound is 74 gram per mole. First, we know that the molar mass of this organic compound, which is C4H10O, N, which we talked about previously. We have to determine this N to find the molecular formula of this compound. The molar mass of this compound is equal to 74 grams per mole. Then 12 times 4, the molar mass of carbon times 4, plus 10 times 1, plus 16 times 1, times N is equal to 74. If we add these, then we get that 74 times N is equal to 74, then N is equal to 1. We write here 1 instead of N, then we get that the molecular formula of this compound is C4H10O. Now in this application we will find the molecular formula of the compound directly without finding its empirical formula. The combustion of 5 milligrams of an organic compound containing carbon, hydrogen, and oxygen produces 12 milligrams of CO2. and 6 milligrams of water. Find the molecular formula of this organic compound if the molar mass of the compound is 74 grams per mole. We found the percentage of biomass of carbon, which was 65.4%, and the percentage biomass of hydrogen, which was 13.2%, and the percentage biomass of oxygen, which was equal to 21.4%. We apply the law of definite proportions, which is molar mass of the compound over 100 is equal to 12x over the percentage biomass of carbon plus y over the percentage biomass of hydrogen plus 16z over the percentage biomass of oxygen. We take the first two fractions, say that molar mass of the compound over 100 is equal to 12x over the percentage biomass. The molar mass of the compound is 74 over 100 is equal to 12x, which is the subscript of carbon, over the percentage biomass of carbon, which is 65.4. Then we find that x is approximately equal to 4. Also, the molar mass of the compound over 100 is equal to y over the percentage biomass of hydrogen. Then 74 over 100 is equal to y over 13.2%. Then y is approximately equal to 10. Finally, to find z, molar mass of the compound over 100 is equal to 16z over the percentage biomass of oxygen. Then 74 over 100 is equal to 16z over 21.4%. Then z is approximately equal to 1. Then the molecular formula of this organic compound is C4H10O. Let's solve application 3. The empirical formula of glucose is CH2O. Find the molecular formula of this organic compound if the molar mass of the compound is 180 grams per mole. First, we know that the molar mass of the compound CH2O N, which was the GCD of the subscripts, is equal to 180 grams per mole. We have 1 carbon times the molar mass of carbon, which is 12, plus 2 hydrogen times the molar mass of hydrogen, which is 1, plus 1 oxygen times its molar mass, which is 16, times N is equal to 180. Then 30 times N is equal to 180, then N is equal to 6. So the molecular formula of the compound is CH2O. Instead of N, we write 6. Then it is equal to 6 times 1, 6. Then it is C6. 6 times 2, 12. It is H12. And 6 times 1, 6. Then it is O6. Let's sum up what we have seen in this video. First, to find the percentage biomass of carbon, we use the equation of combustion of carbon. C plus O2 gives CO2. And to find the percentage biomass of hydrogen, we write the equation H2 plus half O2 give H2O. The percentage biomass of oxygen is equal to 100 minus the percentage biomass of C plus percentage biomass of hydrogen. And the law of definite proportions, molar mass of the compound over 100 is equal to 12x over the percentage biomass of C, where x is the subscript of C, y over the percentage biomass of hydrogen, where y is the subscript of H, and 16z over the percentage biomass of oxygen, where z is the subscript of oxygen. This video was prepared by teacher Rania Dhaini, recorded by Mr. Mustafa Tlais, and supervised by teacher Hiba Badawi. Thank you.